So in this tutorial video, we're going to see a new example which can be categorized to one of the problems that we tried to solve previously. Okay, let's see. So here's a problem. So let's say you give it an array of integers. We want to know whether or not the array is sorted. Okay, so what does it really mean to be sorted? So that simply means the following way. We want to say all the elements, you can see all over here. That means every element must satisfy this particular property. As soon as we find out there's any the first witness for this violation, then we can actually say it's false. Okay, it's not the case. Okay, remember that's what we learned from the previous tutorial videos. So we say all the elements must be smaller than or equal to their immediately right neighbors. So what do I mean by that? Okay, so now what I mean is this. Okay, so basically this is kind of the conjunction we want to write. So let's say we give it, let's say for this particular array, let's say for the first example, ns, okay, we want to say ns0 is less than or equal to ns1. Is that the case? Yes. 1 is less than or equal to 2. And also, the second one we want to check would be, let's say ns1 is less than or equal to its immediately right neighbor. So we got 2 less than or equal to 2. That's true. Okay, and then finally, we want to say over here, let me use the blue maybe. We want to say ns2 is less than or equal to ns3. 2 less than or equal to 4 is going to give us true. You can see that's exactly 0, 1, 1 and 2, 2 and 3. ns1 is the right neighbor for ns0. ns2 is the right neighbor for ns1. And ns3 is the right neighbor for ns2. So now, question for you is, would it be necessary for us to say and ns3? Because typically when we run a loop, the counter for the loop should be 0, 1, 2, and the last index 3, right? What if I say this? If I follow the pattern here, right neighbor for 3 should be ns at position 4. So now here comes the problem. If you try to write this, there's no index 4 over here for the array. So what you will get is array index out of bound exception. Out of bound exception. Okay, so that's why. But we're going to see exactly how we can write a loop to patternmize this. Let's see one more example. Okay, let me use a highlighter here. So now we want to say ns0 is less than or equal to ns1. So this is simply just true, right? So the orange part is simply just true. Okay, what about the second one? Let me choose pink. So now we say ms1 is less than or equal to ns2, so the pink one. So would that be true or false? So 4 less than or equal to 3? No, that's gonna be false. Okay, finally, if you do the third one, so now ns2, so now if we got, let's say ns2 less than or equal to ns3. In this case, 3 less than or equal to 3 is going to be, is going to be true. So we got true and false and true, right? True and false and true. So that means we're going to get false eventually. But now we notice that since we learned about from the previous tutorial video in version number 4, we can make the state condition of the loop a little bit more sophisticated so that as soon as we see the very first violation witness, we're going to exit from the loop. That's exactly the application I would like you to do for this particular example here. Okay, so now if you want to try by yourself, pause the video for now, and then try to think about how you can solve this particular problem over here for checking to see if the array is sorted by using version number 4 for the all positive program that we did develop previously. See if you can do it by yourself. Okay, and then you can play the video again. Okay, assuming that you already try yourself to try version number 4 to solve this problem here, let's do it together quickly, and then I'll trace 2 examples for you. Okay, and then we are done. Okay, so now what I will do is let's create a new class for lab 4 over here. So now let's say new, and then I would say new class, and then I would say is sorted. Is sorted. Okay, only one version here. You can definitely try version number 1, version number 3 on this particular problem here with accumulation, or try to scan through the entire array. That's completely up to you as an exercise. I'll just show you one version there, which is using version number 4. the main method over here. Okay, let me put a note for you. We solve this problem by applying what we learned from all positive version number 4. Okay, that's something you want to figure out exactly why they are related. Okay, that should be quite obvious for you. Okay, so let's try to create a different array. Let's say integer array ns is, let's say the first array, I will simply make it then 1, 2, 2, 4. Okay, that should be sorted, right? And then for integer I is assigned to 0 over here. Okay, that's the first one. And then I would say, oh, let's declare Boolean variable. Okay, so now Boolean variable is sorted because I know eventually I want to use the so this is more like all elements satisfying a particular property, so I need to use conjunction. So that means somehow I want to use conjunction. So now that means I have to initial value should be just true. Okay, but the true here is more relevant for version 4 about the state condition, which we'll see. Okay, and now here I can say as long as I is strictly, okay, how about I put is sorted over here. Okay, as long as so far the part of the array I've looked at so far is sorted, and also I is strictly less than a dot length minus 1. Okay, you're gonna see exactly why. Rather than a dot length, I'm gonna say a dot length minus 1, simply because of the issue I talk about over here. About if you simply go all the way to a dot length minus 1, it's going to give you some array index out of bound exception. Okay, that's something you want to pay attention to. Okay, okay, should not be a, should be ns. Okay, and then we're gonna do this one here, and then we're gonna say is sorted is simply reassigned to, let's say we don't have any accumulation because we already got early exit, right? Oh, I forgot. I say semicolon I plus plus. Okay, it's sorted, and then you simply a I, the current one, less than or equal to its immediately right neighbor, a at position. So now a plus 1. Okay, you can see this one is interesting to really trace together. Should be ns. Sorry, keep getting that wrong. Okay, I'm talking about an index I and also an index I plus 1. So that's what I want to do. Okay, so now what I want to do is I'm going to trace the code together with you. Okay, so now let's first of all, let's run it quickly, okay, and see if that will work. Okay, the first example we will try will be just 1, 2, 2, 4. So what do we expect to see? We expect to see true. Okay, so now let's simply run this program over here. Oh, let me just print out something here. So system.out.println over here, I would say array is sorted. Is that true or false? Okay, and then we're gonna say is sorted. Okay, that's what we'll do. Okay, so now let's see, right click on this and then run as Java application. The array is sorted is simply just true. That's good. Let's try another input over here, the one we just illustrated. Let's do this one quickly. So 2, 4, 3, 3. Okay, and then I'm gonna execute the program again. You can say run. It's gonna say is sorted is false. Okay, seems to work because 4 less than or equal to 3 is the first violation witness that we find, right? Okay, let me just go back to the very first example over here. Oh, actually, we can start with this. That's fine. So now we want to trace the program all together. Okay, so let me just only copy. Let me just say copy and paste. I'll only copy this part of the program. Okay, and then just that. Okay, that'll be enough. So I'm going to trace this particular program here using 2 examples, and then the rest of the other alternative versions using version 1 or version 3 is up to you. Okay, so now let's go to the first one. Okay, the test case number 1, where we do expect the result to be true. Okay, let me copy and paste the program over here. Okay, so that's the program we just developed. So let's run it quickly. Okay, so now what we have is, so we have over here, let's say ns over here is simply 1, 2, 2, 4. That means ns the length will just be 4, right? So now ns length minus 1 will just be 3. Okay, let's just make sure we understand this particular value here. It will just be 3. What does 3 really mean? 3 basically denotes the last index of the array. And then we say that it should be strictly less than the last index of the array. That means that we're really talking about this is the largest index you can get into inside the iteration. Okay, so we're going to see that. And then we're going to see, okay, that's 3. Okay, let's try to see the state condition over here. So now let me just get rid of this. Let me write something that's more sophisticated for you. So what we want to do is sorted and also I strictly less than, okay, we already figure out exactly what this expression should be. In this case, it should be 3. Okay, that's what we want to do. So now let's try this. Okay, so now in the first example over here, how many iterations do we expect to see? Okay, let's see exactly how it's going to work. The first iteration, I would just be initialized to be 0. By the way, is sorted is initially true. Okay, and then I is initialized to be 0. So now let's try to calculate that. Is sorted is simply true. And then and I is simply 0. 0, oh, okay. And 0 less than 3. So that means this is true. True and true is going to give you true. That means we're going to evaluate this particular expression over here for the first time. Let's try that. So now we got is sorted is reassigned to ns at position. So now I would be 0 less than or equal to I plus 1, right? ns at position I plus 1. 0 plus 1 will give you 1. Okay, so now that means we're comparing these two values. ns0 is this number here. ns1 is this number here. 1 less than or equal to 2 is going to give us true. So ns0 less than or equal to ns1 is going to give us true. So that means we're going to reassign true over here to is sorted. Okay, it's just going to be reassigned to just true. Okay, so is sorted will just be true. So now what about the second iteration? At the end of the first iteration, we're going to actually increment I by 1 as usual. So I would be incremented from 0 to 1. So now what do we calculate? So is sorted, the current value is still just true. So now that will be true n%. So now what about I? In this case is 1. 1 less than 3 will still be true. So true and true is going to give us true. That means we're going to evaluate the body of the loop for the second time. So that's what we're going to have. Is sorted is reassigned to ns, position I will be 1 here, right? What about I plus 1? It will be less than or equal to I is 1. 1 plus 1 will give us 2. Okay, so what are we trying to evaluate? Trying to evaluate to say ns1 less than or equal to ns2. Okay, so ns1 less than or equal to ns2. So ns1 is 2, ns2 is actually 2. 2 less than or equal to 2 is going to give us true. So that means we're going to reassign true to is sorted. It's going to give us just true. Still. Okay, so far so good. So now it seems like we got one more iteration to go, right? Let's see. So now let's try the third iteration over here. So at the end of the second iteration, I will be incremented from 1 to 2. So now 2 over here. So what do we have for is sorted? It's simply true, right? So now we got true over here, and the I value is simply 2. 2 less than 3 is going to give us true. So true and true is going to give us true. Okay? So now that means we're going to evaluate the body of the loop for the third time. Okay? So what do we have? So now if we have that, so that's going to be is sorted is reassigned to NSI, I is 2. NS at position 2 less than or equal to, and then NS I plus 1. NS, so 2 plus 1 will give us 3. So we are really trying to evaluate NS2 less than or equal to ns3, right? ns2 is 2, ns3 is 4. 2 less than or equal to 4 is going to be true. Okay, so ns at position 2 less than or equal to ns at position 3 should be true. Okay, so this will just be reassigned to just true, right? Whatever it is, going to reassign to is sorted. Okay, so far so good. So now, should we, as we said before, if you ever try to say ns3 less than or equal to ns4, this does not make sense because this will give you array index out of bound exception. This is why it is so important. So let me just show you very quickly. Okay, you can try this on Eclipse very quickly for yourself. Okay, for this state condition over here, you can try the following. So the correct version is simply to say I is strictly less than ns dot length minus 1. Okay. However, if you try the incorrect version, which are right here, you can try. Okay, I'm not going to try on Eclipse. You can try it for yourself. You can say I strictly less than ns dot length, which we do typically. So this is not going to work, simply because you're going to run into the array index out of bound exception as we try to explain. And the reason is you got I plus 1 for the index over here. Okay, so now let's see what's going to happen. At the end of the third iteration over here, what we're going to have, and let me just use maybe green over here. At the end of the third iteration, we're going to increment I further, so it will be incremented from 2 to 3. So now how do we evaluate that? So now let's try this. If you say it's sorted, it's still true from the last iteration, right? So that'll be true over here. And then what about the I less than 3 over here, right? Which is exactly what we are checking over here. I is 3. Less than 3 is going to be false. So you got false and true, which is going to give you false eventually. So that means the fourth time that we are trying to evaluate this state condition over here is going to give us false. So we exit from the loop. So we bypass the body of the loop, and then we exit from there, and then we simply system the outer print line. Array is sorted, and the last value we got is simply just true. So the array is sorted. Okay, hopefully you can see exactly how the state condition becomes false because the right hand side of the conjunction over here becomes false. So now in the second test case, I want to show you the state condition becomes false because a different operand. That's why I want to show you both examples. Okay, let's see the second one quickly. Okay, I'm going to copy and paste the same block of code over here. Okay, simply just here. Okay, I'll put it here. So now let's have a look at the same block of code, but it's going to be a different test case. Okay, so let's see exactly how things will work. So now let's see, conceptually, let's think about what's going to happen. We know that for the very first iteration, we're going to compare these two numbers, right? 2 less than or equal to 4, which is going to be true. The second iteration, 4 less than or equal to 3, is actually false. That means we don't actually have to go on to check to see if 3 is less than or equal to 3. We don't have to because we got an early exit handling over here, right? Okay, that's a very quick sketch, but let's trace it precisely. Okay, so now we got it sorted. Initially, it's simply just true over here. Okay, and then so now let's try to evaluate that again. I'm gonna just get rid of this, and I'll make sure the state condition is right. It's simply going to be is sorted and I strictly less than. Okay, again, ns the length in this case will just be 4. 4 minus 1 will just be 3. Okay, just make it easier for us to trace. So now the first iteration over there, I will just be 0. It's sorted initially is simply true. And I will be 0 less than 3. This is true. True and true is going to give us true. That means we're going to go into the body of the loop to execute it for the first time. So what do we have? Is sorted is reassigned to ns at position I, which is 0. Is less than or equal to I plus 1, ns at position 0 plus 1 is going to be 1. So what are we trying to compare? So, okay, let me write it down first. ns0 less than or equal to ns1 over here. So now that means we're comparing these two elements over here, right? ns0 is 2, ns1 is 4. 2 less than or equal to 4 is going to give you true. Okay, that's going to be true over here. So that means we're going to reassign this expression over here, which is true, to is sorted. So reassign that to true. Okay, that's the first iteration. Let's see what's going to happen in the second iteration. Okay, so now what we'll see is, let's say orange. At the end of the first iteration, we're gonna increment I by 1. So from 0 to 1. So now we're gonna evaluate this state condition here. Okay, sorry. We're gonna evaluate this state condition here for the second time. So what we'll do is the current value for is sorted is simply true. Okay. So now we'll say true, and the value for I is simply 1. So 1 less than 3 will be true. So true and true is going to give you true. Okay, so far so good. And then we're going to execute the body of the loop for the second time. So what do we have to execute? We got is sorted over here is reassigned to I value is 1. ns at position 1. Less than or equal to ns at position I plus 1. 1 plus 1 will be 2. So ns at position 2. Okay, and then, so let me write it down here. ns at position 1 is less than or equal to ns at position 2. So we are really comparing these two elements over here. Okay, these two. So now ns1 is basically 4. ns2 is basically 3, right? So you got 4 less than or equal to 3 over here. Apparently that is false. Okay, you just got false over here. So now let's see what's going to happen. So that means you're going to reassign the result being false over here to is sorted. So that means you're going to replace this true over here just by false. Okay, so far so good. And then, so once we reassign the is sorted to be false, what's going to happen now? What's going to happen is, at the end of the second iteration, we're going to, let me use a different color, we're going to increment I by 1. So that means it will go from 1 to 2. Okay, so now how do we evaluate this particular state condition over here for the third time? Okay, so now we're going to get is sorted over here has been reassigned to false, as we just explained. So it will be false. As soon as you see the false over here, you know that it doesn't matter what the right hand side is, even if it's true. But let's see for completeness. So I value is simply 2. 2 less than 3 will just give you true. So you got false and true, which is going to be false. What does that mean? If the state condition evaluate to false, we're going to bypass this particular block of code, being the body of the loop, and we're going to bypass and exit from loop and go to the print statement right away. So we're done for the iteration, right? If you try to compare this particular example over here with the previous one, you can see the previous one we got 1, 2, and 3 iterations, because every pair of elements in its right neighbor satisfy the property. So that's why we could go all the way to the end. On the other hand, for the second example here, as soon as we see in the second pair over here, it violates the sorting property, which means 4 is not less than or equal to 3. In that case, we'll simply exit earlier. Okay. So now finally, if you actually go exit and then we say system out of print line, array is sorted, what will be the value over here? Well, it will just be false. Okay, which is correct because this is the witness for violation, as opposed to the previous case, it would just be true because we every pair of its the elements in its immediately right neighbor satisfy the sorting property. Okay, so this sorting problem over here is a very simple application of version number 4 that we studied previously. So please go over the code itself, which again is not very complicated. The only let me highlight the parts you really want to pay attention to, and then we're done. Okay, let me just add a new page over here. So for this particular example over here, so there are 2 details you want to pay attention to. Okay, let me make it a little bit smaller. Point number 1, you want to know that y strictly less than, rather than saying ns the length minus length as usual, but we're saying -1. So this is really number one point you want to make sure you understand. Number two, you can definitely feel free to say I, index I, but now I got index I plus 1 to say it's the immediately right neighbor. You can also try to use different index for maybe immediately left neighbor or the previous left neighbor. Right? You can just play with the indices in whatever way you like, as long as you can make sure the way you specify the state condition over here is going to make sure you don't have the array index out of bound exception.